Well, hello again from Skip, Victor Echo 6, Bravo, Golf Tango. Well, I'm fortunate enough to have another IFR 1200 to repair. This poor thing has seen its better days. I've been abused. I'm going to say, has it been abused or am I going to be abused? So we'll see. I actually wasn't going to do a video on this because really all I was going to be doing to it was kind of a maintenance on just cosmetic. There's some broken pieces here and there, and well, it turned out to be a few more issues, and it got quite interesting. So I decided, well, I'm gonna make a video of it. So the first part here, I don't have a lot of pictures of things of what I did, so you have to bear with me at lack of pictures. This thing was pretty ugly looking. What I really noticed right off was the faceplate, the front panel it looked like it was peeling the clear lacquer off it. I think what it was anti-glare plastic. So I decided I'm going to fix that too, and which means turn it down. The keypads had problems, so I decided to tear it right down to the bare bones and clean this thing. I did do an overall check and everything, and it seemed to be running. They were complaining about the power supply quitting on them, so I thought, well, right now it seems like it's working. I'll look at that later, and I started it this way. Like I say, lack of pictures, so it's kind of all over. This weird peeling was just, I don't know, like I say, an anti-glare coating that was coming off. So I stripped it down, and what I did was I took I used one of my old plastic credit cards and isopropyl alcohol, and I just worked on it. A little bit of elbow grease. Some of it just peeled off like crazy. Other rest, some of it was just tough to come off, but it finally came. The backside needed a bit of a cleaning too. It had some scroty stuff coming through the buttons, but anyways, when it was all done, it looked 100% better. Just nice and shiny. Like I say, I think it was an anti-glare because now it really shines. So there's lots of parts, so now it's time to see if I can get it all back together and running was the big thing here. Some of these pictures are in reverse from when I took it apart and when I put it together, but it's the same idea how the assembly went. Keypads, I took them apart and cleaned all the contacts and just slowly put it together. So I went together one piece at a time. The wiring harness itself kind of just plugged on, but there were the 3 B and C connectors, and they had brackets that had to be put together. So took a little soldering there. But metering faceplate or metering circuit board, it just goes on top, and it went together nice. One of the B and C jacks was badly worn. The fingers were broke off inside, so I decided to replace it. And they're not cheap, but oh well. And then the vernier knob and the the control for the attenuator had to be reassembled. These pictures are when I was taking it apart. That's why you still see the peeling, but it shows you the different stages and how the fine attenuator is done with a gear. It uses a pot in behind with another small gear, and it just rotates a pot, I guess, and it controls the voltage back into the oscillator circuit or something. But anyways, it wasn't too bad. I was more worried about trying to get it calibrated, and it turned out to be a piece of cake. So it came together, and I was almost ready to put it back onto the main chassis and get it fired back up again. I didn't bother doing the knobs until the whole thing was put together, but I noticed when I was doing a preliminary check, the controls to the oscilloscope were quite noisy, so I wanted to get some spray in this rotor control, and you can see they're quite sealed up, so I just loosened off the bolts and nuts on each 4 corners and took an X-Acto knife and was able to spread it enough just to get some spray in there, and that fixed it. It worked nice and smooth after that. No noisy contacts and that sort of thing. Anyways, it finally came together, and I got it mounted on the chassis. And forgot to mention one other thing I'd replaced was the switch for the scope input, the AC/DC ground switch. That toggle broke off, so it got replaced. But anyways, you can see in the picture here, it's back on the chassis and it's working. The other thing I found in this poor old thing is the whole back plate was loose. It had been badly dropped on it, I think, over the years, and the screws had been sheared right off, and the holes been tore. So I just got a drill, drilled new holes, tapped it, and moved the screws over and that sort of thing. So it's good and solid now, but it's seen its better days. This thing also had the old battery in it still, and it had leaked all over the place, so I had to get that cleaned up. And we did do a power supply upgrade on it also. may not have needed it, because what I found was the AC socket was half out of the hole and it would not fit back in the hole. I actually had to take a die grinder and reshape the plastic to get it to fit in there tight, and so the AC plug wasn't going into the socket real tight, and it might have been all it was, but oh well, it's she's a good unit and brand new now. So it seemed to be all good, so I decided poor old case, the enclosure was badly scratched and dented, so I did some body work on it and sprayed on my favorite color, gray, of course, and reassembled it. So it was all back together. Things looked good, so I started doing some more testing on it, and it was at this point here I noticed something. Actually, I noticed it before, but I didn't pay that much attention to it, and I thought, there's an issue here. And this is when it started, the elderly abuse. I don't know, but anyways, it was fun. But oh man, I did have some moments. The old brain wasn't working quite right at times, and I should have known better. But that's all in the fun of it. I got into some parts in this IFR that I'd never been into before, and I've always wanted to look in there. So good at times any, I guess. Well, this is what I'm talking about. Let's turn the volume down. We need this noise. I'm on a local station, FM station 98.9, and it's on the scope, but it's just horribly, and there it is. It's coming in good. And I mean, I'm used to that. But it's when I hooked up the signal generator here into this thing and checked the sensitivity, and I noticed there was something amiss. We'll show you that. Okay, so this is it hooked up to this other generator, and I got this generator locked on frequency with an external reference. And you see, I got a good scope here. I mean, there's a good signal going into it, but you can hear it. And we're at negative 55 dBm. I compared it with my IFR over here, and it's works at negative 100. You know, it's that much more sensitive, and just watch how this performs. So you can just watch the, probably can't see the frequency, but mainly the needle here for the frequency here. That's what we're looking at. When I'm cranking a signal. There's negative 49. There, it finally clicked in. It's finally working at a signal that I can detect. You know, frequency here is negative 0.2 and all that, but I got to really cram a signal in there for that to work. So that's where the sensitivity problem is on this thing. I didn't even catch that before. I didn't even think of it. So good thing I checked. Way different with my other IFR. It's like negative 100 dBm going into it, and the frequency here system's working. So somebody's crammed too much power to that jack. Damaged it. So, poor sensitivity on the antenna jack. This is what I see when I use the ohmmeter to ground. So, ground, center conductor, 2.6 megohms. Just to make sure it's just one diode or something there. 2.6 megohms. There's a 5.6 megohm resistor off this antenna jack through two diodes back to back to ground as protection circuit. Somebody has put too much power in here and blew the resistor. So this is where the fun begins. So another IFR, and like I said, I was fixing this thing up for some friends, and I didn't think it'd be much here to really do for a video, but I've come across an issue with the antenna sensitivity. It sucks. The schematic shows a 5.6 ohm resistor through diodes to ground, and it's wide open. So somebody's put some power into the antenna jack. The whole thing's upside down here. It's the IF block, it's called, and the antenna comes into this piece of coax right here, this hard line, this skinny one, and it goes way down, if you can follow it there, and it's buried. It's the bottom of this pile, right where my orange knife is, down in there. So I've got to rip all of this out of here to get at it, because it's probably got this 5.6 ohm resistor. It's a protection resistor, and it's, take my ohmmeter to ground, it's wide open. So, oh boy. I like working on these things, but sometimes I wonder. Oh well, here we go. Oh yeah, I'm having fun. Getting all these coaxes off here. I don't know if you can see what I'm doing or not here. First off, I'm going the wrong direction. My little wrench down in here. Nope, she's going to be miserable the whole way. I've marked everything. Sure, I got the manual, but it just works better this way. I don't know if I can get my... No, fingers are too big. Gotta get this block out of here. I don't know. That's where the antenna goes into there, and it's on that jack where the 5.6 ohm resistor is inside this block. Oh yeah, fun and games. We'll get there. Okay, well, I'm taking a long screw out of here. I got it disconnected. It should come loose. Got a long screw out of here, and it's still not coming out. But it's I'm thinking there's a screw there, and maybe one under here. So, excuse my fingers. I'll take this little block off here. Uh-oh, nothing. Oh, that's not good. I was hoping to be another screw here. Oh, it does swivel. Good grief. I think it's on the other side. Well, that's really stupid of them to build it like that. I can't see another screw. Oh, I'm going to flip it over and pull boards out and click it from the other side, I guess. What a dumb thing to do that is. Okay. Okay, yeah, flip it over. Got this off. Now I'm going to pull the boards out. Where's my little... I can see a hole down there. I was thinking of bolts down there, but there's a motherboard in the way. So, I just can't. What are we looking at here? Oh yeah, not bad. All right. Receiver board. This plug. This next one is pull this jack off of here. I'll pull this one too on out. Man, I had this thing all together. I can't believe I'm going to tear this apart like this again. Oh well. I can't get at it yet. Oh, next one's a CPU card. There's the bolt. See if I can show that to you. There it is. You can see it there. This one, right here. There's the hole. It's an Allen screw. So we've got to get in there and pull it off. I can put the other screw in so the whole module just doesn't drop out the bottom. But boy, I saw that motherboard and I thought, it can't be in there. But yeah, they got a hole. So at least somebody's thinking when they built this thing. Okay, here we go. Okay, got that bolt off the other side. Boy, it was tough. Didn't want to lose that lock washer down in there, so good thing it's magnetic. So take this screw off again. Long screw. And voila, it's loose. But I still got a pile of cables connected here. Yeah. Good boy. That one there. Bunch over there. She's loose, but no cigar, as they say. We'll get back to it. Okay, well, I got the cables off. This cable has no number, so I just marked it as X. But now she's coming out. Oh yeah, oh, we got a plug good. I was looking at those darn wires. I didn't want all that to come out of there. I'm not sure, like, oh, it's a catch on the box side. Well, that wasn't too bad, not as bad as I thought, but there we are. We got to get inside this thing. Ooh, boy. The resistor's right in here. That means I got to take this off. Oh, crap. Oh, yeah, I said this is going to be fun. Well, we'll get the main chassis the way so we get the workbench on this thing and have a look. Fun. So a few screws later. Not sure what can of worms we're going to get into here. Can't be that bad. all of them. Aha. Where in the hell? Yeah, I don't know if you can see this. I'm gonna bring it close. Here's our jack. Look, nothing but metal in the way. Oh man, does that mean I gotta come in from this side? Oh yeah, it comes in here. There's our two diodes. The resistors from this post. Oh, there's our two diodes right there. If you can see them in a corner. Right there. They're two back-to-back diodes. Hooked to this post. And then from here to the jack is the resistor. Well, I get a sneaky... No, can't do it that way. Jeez. Oh yeah, fun, hey? Can't never be simple. I'm going to check the resistance here first. Since we've got this far with it. Yep. Put there. Oh, look at that. It's 2.5 ohms. That means our diodes are probably blowing. It's supposed to be a 5.6 ohm resistor though. Maybe we won't have to get into there. 2.6. Off ground to here. 2.5 megohms. I think those two diodes are blowing. Well, let's see. Nope, 0.659. Would I see that much resistance through all that? Oh crap. I guess I should have checked it with the diode checker. I hate to say it, but there's nothing wrong with that part. Oh boy. Okay, then we got a front end. There's a bunch of other things to do. I got a schematic out and check, but I bet there's a amplifier in there that's probably gone. Oh, back to the schematics, but we're getting there. Boy, oh boy. Okay, it was at this point where I realized I been having some senior moments and I really screwed up. But hey, I'm having fun. That's what counts. So here's some schematics to show you what the hell I've been doing. Okay, this is the schematic of the IF block, they call it. And where I was dealing with is, I was dealing mostly in this area right here. So here's the antenna in. And you can see right here in this area, that's that resistor I thought was open. And here's the two diodes that I thought was maybe open. I should have been measuring with the diode checkers there, and I've seen just the resistance of the diodes in normal ohm meter position of the meter. So I don't know where I was. Head was gone somewhere. Anyways, how this works, it comes in here. And this whole area right here is what they call this. This whole section is what they call the static protection, and it's basically just to keep it from garbage coming through the antenna jack and frying this preamp. This relay here, when this thing is working with no transmitter coming in through the TR jack on the front panel, there's a 12-volt line coming in right here, and it energizes the preamp, energizes relay. So the signal gets amplified, goes through the relay, and passes along. This is the front-end amplifier. If you're coming in with some power, this 12 volts is taken away, and I believe it comes through this line, then through the relay, and out. In other words, this whole circuit is disconnected and unpowered. In fact, the output is even grounded right there. So anyways, so where we're dealing with the antenna. So it comes along here, and comes up through the filter, comes to a local mixer here, and right now it's at 1300 megahertz, goes along here, goes down to this circuit. More, I don't know what they're doing here. It's I never got into it. Anyways, there's another mixer here, and this is where it heads out at, I think, about the 70 or 80 megahertz part of the spectrum. And I'm looking at this, and it finally hit me. Says, okay, if I'm seeing the signal good on the scope, why do I think this is bad? Because this is the amplifier for the whole front end for the scope and the speaker and the meters and everything else. So it finally hit me. Said, "You're on a wild goose chase here." I don't know what I was thinking about. One of those senior moments, but I saw some interesting stuff though. So I'll talk about that more in a second here. Anyways, I'm on a wild goose chase here. I got looking into this thing, and it's the box, the hole at the top there where the circuitry I'm in with the preamp, and got in there looking at things, comparing it to the schematic and looking at things, and then I realized, I says, this is really different from what the schematic shows and what the parts layout shows, and this is so I drew it out, and this is what it looks like. It's a different model altogether. This is what's inside that front end IF block. Instead of a transistor, they look like what appears to be an MMIC, probably like an ERA3. Seems to work. I did a kind of a gain test on it. I could take my active probe and see like a 10 to 12 dB increase in gain, so it's working. So I wondered, okay, the signal gets to the scope, okay, how's it getting back to the rest of the machine? And well, I followed the path, and sure enough, it comes in here, and right through the jack. It doubles back out and heads back to the IF block, if you can believe that one. The rest of the signal heads this way over to the scope circuit and out. So there's the split right there. I kind of laughed at myself for that one, but oh well. Okay, so how is the signal being split from the scope and to the rest of the circuit? So here's a simplified block diagram of it all. So the signal comes in through the antenna, of course, into the first part of the IF block, which I was showing you with that MMIC circuit. It goes out of there into the analyzer RF module, and that's where it splits. A good part of it goes over to the scope circuit, which we know works, and then it divides here through the jacks back out into the IF block, but a different board in the IF block. And it's what they call like a 10.7 amplifier, but it's not really 10.7. It's still at 70 or 80 megahertz, but it's being modulated with the signal. Heads out of there and goes to the 10.7 IF module. So this is where we're going to go next, is looking at that one, because it's the rest of this seems to be okay. So I had fun, this part of it. Now I know what's in there. Okay, this is the next step. So always helps to have a spare one for parts, checking whatever, plus my good one over here. So we still got the generator going. We got these both running, and I'm both tapping off the input to the 10.7 IF with a T connector. So we just compare them, and it's kind of interesting, but it tells me something. I look on the scope there, and you can see it's what they call the 10.7. It isn't 10.7. It's more like around 78 megahertz, but I think it's modulated. This is without a signal going into the antenna. When I put the signal into it, it looks like this. And it's kind of what the book shows. I think I'm really hitting it hard with a signal too. Yeah, negative 50. Let's go down. Level. Yeah, it's not as bad then. So we'll just leave it around there. It's about minus 60. So, okay. So that's that one. Now, we're going to take the scope off of here. Put on this one. A little different waveform, but I'm not even going to worry about that. It's the same frequency and all that. So that's coming out of the one. This is the one that works. Now when I put the signal into it, it looks a little different. It's being modulated, but very similar. So to me, the signal is getting here, coming out of the IF block. So the next step I'm going to do is I'm going to swap IF blocks. So you can see here, look at this is the good one. This is what I'm concerned with. Signal strength is the same here. The frequency here is working. The deviation meter is working. I don't have any deviation coming in, but it's doing all this at this point. Now if I go over to this one, the bad one, I don't even need to hook that up. I'll just go over here like this, put the input in, And you can see I'm on battery here, but the deviation is funny. The frequency error is pinned. It shouldn't be pinned. It's being pinned unless I get the signal up strong enough. If I pound this in there hard enough. There, it's coming. Oh, I'm going the wrong way, sorry. I don't know who's thumping upstairs there, but there it goes. I had to go down to negative 50, and that one there will go down to negative 100. The other one will go to negative 100. It's just, there's something about, and you can hear the noise too. Like, there's something going on there. So I'm going to swap the IF modules just to isolate things and see what happens. So that's the next step. Okay, I've turned it on. I've replaced modules. Here's the old one. The old this is the, I'm going to say bad one. I got the new one there already. Even with nothing hooked up, I noticed the difference. Before, am I looking at? Yeah, before the squelch, I had to go way over here to break squelch and make noise. Now it's acting more normal. It's way over here. Way different. What else can I say? That's the biggest thing. I noticed that right off the start. So, again, the generator, put a signal in. We're still coming off this, and we're looking at, negative 50, negative 49.7, something like that. So, it's a strong signal. As you can see that on the scope. But, anyways, signals coming in. We got center frequency, modulation, and center frequency. It's working. It did before. But how quiet it is before there was a heterodyne. That tells me something. But before, what the problem was, if I went weaker signal than this, like right now, it'd be gone. There's negative 80 dBm. There's negative 90. It's getting noisy, whereas before it'd be around 50, it'd be getting noisy. Plus, the frequency area wouldn't be working, and this would be pinned. There's a problem in the IF board. So, it always helps to have a module. I'm going to go right down to, here we go to squelch. Okay, let's open up. See, I couldn't do this here. Squelch is there. It's still, the modulation and the frequency area is still working. There's negative 100 dBm. This thing wouldn't even hear the signal. So, now we know. Good grief, eh? Like I said, it helps to have parts. Oh boy. So, now we got to tear this thing apart, this module apart, and troubleshoot that darn thing. So, I'm not sure what's going on in there, but interesting anyways. Onward and upward. So another interesting, before I pull the my replacement in there, which is working good, I hook up the my tee-off for the IF going into it and looked up at the scope. The other one was more humped. This is more like the triangle wave I've seen before, so there's something affecting all that. Still same thing when I hook up the generator, I imagine. Let's get on the right frequency. Nothing's changed, no. Yeah, same thing that way, but no, it was different. It was modulating just on the top. There is a difference. So, just thought I'd record that. It's kind of an interesting tidbit why that part doesn't work. That's wild. So I got the lids off. That's what she looks like inside. Comes in here, comes out there, and out of there too, of course. The audio actually comes out of here. There's I think that's the discriminator there. We'll just see. Now we got to get this thing mounted on top so I can plug it in and still troubleshoot the darn thing. So just thought I'd show you the insides of this thing as I got it off. I'm glad it wasn't too badly shielded, soldered like solder. You can't get it, nothing. So this one should be too bad to work on. So I've got it hooked up. Here's the old module. One thing I didn't mention was the good module. I was hoping I could compare points. The shields are soldered on solid, so unless I can work in this part, I can't even. I was hoping to compare test points and stuff like that, but it figures. Anyways, I got it hooked up. It's running, and it's still got the problem. And what we're doing here is putting a signal in from the signal generator. We're at negative 68. And I'm looking at my signal. What I'm going to do here is show you this active probe. I'm going to be looking at the spectrum analyzer at the 10.7 IF signals, what I'm looking at. At this point, I built something here that I've had this for a long time. It's called an active probe. It's like an RF probe, but it doesn't use a voltmeter. So you can get this thing close enough here, the light. Anyways, it's got a nice spring-loaded tip, and essentially it just goes into a FET, dual-gate FET, and amplifies it and sends it out on the coax. And now this I can hook into my spectrum analyzer and actually look at levels, RF levels and stuff. And this is the handiest darn thing. I've had this for a long time. I just never got around to it. It's powered, so you got to run 12 volts to it. But as you'll see, it works like a charm. Of course, wire board is no darn good, so I took a Sharpie and cut it in a way so a little hole in the end, and it fits in. Can't make a better holder. Just fits in like that. There's my my probe, of course, and I want to protect it. I did the other one, but anyway, so there's my electric felt pen for my active probe. You'll see here shortly how well this thing works. It's a cat's meow for troubleshooting RF circuits like this. Anyways, there we go. So when I first got looking in this module, going off the schematic, I already see a difference. This one has another mystery surface mount micro MMIC chip or part in there, and I followed the signal in. I figured, okay, this thing has some kind of a preamp at the beginning. So I took a look at the input. This is the input there. There's the input to the MMIC. So you see it's straight around, slid off. Almost negative 71. I go on the output. Nothing, eh? So I figured, well, that's weird. Is this MMIC? Is this a preamp or what? So I took my voltmeter and I started checking on things. I'm used to these MMICs, and I get in there. So I look on the output, and 4.8 volts. That seems kind of low, but whatever. I look at the input. 4.8? No, this ain't right. So let's look at the ground. Look at the ground leads. 4.8. The other ground lead. 4.8. Oh, jeez. How can this be bad? How can I have no ground on these things? And it was a puzzler. So at this point, I went back to the schematic, and I'll show you a picture of what this thing looks like inside. That's the MMIC, that little black speck right in the middle there. Get my big finger right there. And it seems to have no ground. So I spent a bunch of time. I took this board off, and I studied it and studied it. I drew some little schematics out, and I'll draw you a little diagram here in a bit. But anyways, it comes over. The ground side is not grounded. There's a lead that comes over all the way over to this transistor right here. And it's an NPN switch to ground. I followed the base connection to the connector and figured out what this was, and it's a generator activation. This darn thing's used on the generator, not for a C. So I flipped over the generator, and sure enough, it grounds and it amplifies, but so it's no good at all for what I'm doing. Okay, this is the front end or input to that 10.7 module. You can see the mystery MMIC there. Signal comes in from the IF block or from the RF analyzer board, and comes in here, and it's and both they call it 10.7, but it's actually more like 70-80 megahertz modulated with 10.7 signal. So it comes in here, and this is where I was looking at it. Was coming here. Now this is really a mystery, because I'm going by the dot on the part itself, which usually means output, and that's be right here. The input's got 5 volts going through the coil, and the output's going to ground. I don't know. Like I say, it's a mystery part, so I don't know if I've got this drawn right, but whatever. It doesn't work until the generator control is on, grounding it out, and then it does something. Ignore it. I followed it out, and it splits, signal goes in here, and goes into a transformer, which makes more sense, and this is now conventional drawing on the original schematic. So this transformer is more likely the 10.7 filter, we'll call it, and then feeds on to the rest of the circuitry. So yeah, another mystery. We'll see I'll show you the original schematic here eventually, how it works, but yeah, so I spent a few hours waste my time trying to figure out what that was doing. And like I said, this is not in the schematic, the original schematic, so it's something new they've added, I guess, just like the other one. Weird and wonderful. So I was off on a wild goose chase with that MMIC. It's not in the schematic. It's something different again. So I studied it again underneath, followed the path. I found a second line that the signal follows to, and I'll see if I can follow this here. So my input going into R12. This is the input to the first FET. Bear with me. R12. There it is there. So this is the signal going into it. Right here. This is a dual FET. So that's going into the FET. Now, if I could find a way to go out, it's on this one here. This is the output. It's less. That makes no sense. Here's the input. Here's the output. Just going to check a couple spots. Yeah, same thing. So right there it tells me something. I got the first amplifier in this IF strip is not putting out. I'm going to go to the second one. There's 2 in this. I'll show you in the schematic, by the way. Okay, let's see. Yeah, it's going to be difficult. Let's go here. This is the output of the second one. And there's no gain at all. This is the input to it. Here's the output to it. I mean, there should be amplification going on here. It just isn't. So I got a little puzzle. So I kept going on. Anyways, I get over here, and this is the diode switching arrangement. If I can follow it here. Yeah. This is the diode switching for the 3 filters, 3 bandwidth filters, and then I go over to the output after going through the filters, and come on, get on there, you silly thing. You know, it's just, I started off something stronger, and this is where I'm at. Okay, going through filters, I expect some loss, but no, there's something not right in this IF strip, which, duh. So I'm just going to pause the video here and get ready for the next shot. I want to, at this point, there's 2 FET amplifiers. I want to see what the voltages look like. So the first one, I'm going to look at, these are 2 dual gate inputs. So the first one I'm going to look at is right here, if I can find it again. R20. Oh boy. Yeah. Right here. It must be on the input because I can hear a bit of hiss coming on. So anyways, 2.7 volts. To me, that looks kind of normal. Now we'll look at the. Let's look at the output. That's on this one. Where are we at here? 11.57 volts. Hope this is coming through. Yeah, you can see that good. I like the activity showing. I'm going to put the lead on there. Anyway, 11.57. So that's something. Look at the other gate. input. And that is right here. A negative 0.23. That don't sound right. Should be negative. So that tells me something right there. I'll go to the second one. And if I can find it here. Oh boy. R21. Right there. That sucker. 15K, R21, 15K. Right there. 2.7. Very similar to the other one. Now the other gate input, well, let's look at the output first. That's this puppy right here. 11.43. It's very similar to the other one. Now let's look at the other input. That's R33 right there. .8 positive volts. That sounds better than negative like the other one. So there's something about this first preamp that, or first amplifier in this IF string that is that negative voltage. That don't sound right. So let's see. So this is the IF module I've been looking at here with you, and that mystery MMIC circuit I was showing you in the block diagram before was in here somewhere, and of course in this one it doesn't have it. Anyways, here's the what they call the 10.7 IF input, which is that 70-80 meg signal, and so the way the signal works, it comes in here and it goes through these two IF amplifiers. This is the first one. Here's the second one. Supposedly it gets amplified by them. Comes down here. It'll be selected on the front panel which IF filter it goes through. Bandwidth filter here, which is 3 crystals and another associated amplifiers or whatever. Actually, 2 crystals per filter I see here now. To another transformer and to another amplifier of some sort here, right here. And this is where it divides up. So here's our FM demodulator circuit. So it'll head down here, something like this, like this, like this, like this, into the demodulator circuit and back out again. And this is the FM audio output coming out here. And this is the 10.7 frequency counter. It's an actual nice sine wave coming out here at 10.7 IF. I believe it has something to do with measuring the frequency here. Don't hold me that one though. The other path, back up here again, is this one. It splits and goes up here to another transformer. Oops. Okay, be miserable. And through this voltage comparator back out again. They call this AM audio output, but it's a simple detector circuit. I imagine if it had AM going into it, it probably would give you AM audio, but in the FM mode, it's merely taking the FM carrier, 10.7, and I believe rectifying it here and giving you a relative output to the AGC circuit. That's how it works. Now, what I've been looking at here is in this area. This is Q1, this is Q2, and I'm seeing the 2.7 volts here, and this is the leg here that I'm seeing the negative 2 volts. Doesn't make any sense. You notice it comes back into these two circuits here, and it's something to do with the AGC input. This one, again, the second gate input is this one here, but this goes like I think I said 3.8 or 2.8, something like that. It's also connected to the AGC circuit, but there is some isolation here with the resistor. And it also heads down, goes back over here, and controls, I think, this gain on this one. So that's how it works. Now you'll see here next how what I was dealing with. So I've determined that there's an AGC circuit to control that first gate. And what I did was I've disconnected a resistor that sends the negative voltage in from, it is actually negative voltage, comes in from the audio board over here. It processes it. It comes out what they call the AM audio output. It makes no sense. There's no AM audio. It actually is just an AGC voltage developed over here. that gets fed back over to the audio board, processed, gets fed back in here, and that's what controls the AGC. It's done by an AM output, but actually what it is, it's the IF. It's just, the IF is split off into two directions in here. One for the FM demodulator, one for this AGC circuit. Weird they call it AM, but oh well. Anyways, you can hear the weird sound, and we're going in at it here at negative 63 dBm on the generator here. It's good on the scope, you can see it there, but the needles are pinned and it's not working right. So I'm going to disable this AGC circuit coming into it, and what I did is I pulled one end of the resistor, I put a wire on it, and I could disconnect it on and off. So this is what happens when I disconnect it. Now I want to show you something else here too. Let's look at the look at the voltages, or signal, I should say, amplitude. Let's look at yeah, hold it there. This is the output of the whole IF circuit, and this is the input to one of the three switching diodes for the filters. Now when I disconnect this, look at the difference. Huge difference. I mean, it's really strong. You can hear the needle, nice and quiet. You know, it's just full quieting, and the gauges are working down below. I can't hardly see them in this, but the gauges are working. So I'm going to go back to the scope here. I'm just going to go back and show you a few stages here. This is the output of the first amplifier. Look at that, massive. Output of the second amplifier, massive. So it's an AGC problem, and like I say, this is I've gone through this now real quickly. I'm simulating all this because I've done all this already. We'll look at the input from this AGC line. Get a voltmeter going here. See it? Yeah. Well, yeah, glare. That's better. The AGC coming in. Oop. Is negative 10. I connect these two together so the AGC problem's there, and it drops it down to negative 5. So there's an AGC issue. And what I've, it isn't out here because I've replaced this module with the new one. Not new one, but a second one, and it works. So there's something in here that's not being processed right. And yeah, I went on for a couple hours, a couple afternoons on this one. It's been interesting. So, like I said, I spent a few afternoons going back and forth, and not really getting anywhere. And I'm thinking, okay, is it here or is it the audio board? Now, I did put the new module in here, and it worked, but I don't know if you've been like me. I've done things like this, and I put the new module in this thing, the thing works, and so you think, okay, it's in the module. But I have been in situations where it was just a different characteristic of that other module, and something else was being affected. And I thought, is it the audio board where the AGC is being developed that gets fed back to this? So at that point, I thought, okay, we just got to isolate things here. So I took the bad board. That's what this one was. I'm not going to do it again, but I took this one anyways, and I put it in my good working spare unit. And the problem followed it. So different audio board, same bad IF module. So I'm convinced that it's the IF module creating this AGC problem. So I went back to here, and happy with myself that I got this far with it, but what's creating this problem? So at this point I said, okay, it's a loop. It's like a phase lock loop. That's how I always recognize things like this. You got a thing that's going around in a circle. It all affects each other. To me, it's divide and conquer. So I've decided I'm going to, where the AGC voltage is being detected and sent out of here back to the audio board to be processed, I'm going to cut it and take my power supply up here, introduce my own voltage into it as a controlling voltage, and see what this thing does. And that was my next plan of attack. So we'll carry on with that part. So this is my plan of attack. This is the output part of the module. as again I show you the 10.7 signal coming in here, splitting, one going out through the audio circuit. Then this one goes up here into the, they call AM output again, like I said before, and it's the AC voltage detected. So what I'm going to do is I'm going to pull this coil right out of here. Not out, I'm just going to lift one end out, introduce my own voltage in this point so it goes out to the audio board, gets processed, comes back in at the other part. So this is the coil I'm going to be dealing with here, lifting one end out. We'll see. So that inductor I was showing you, that's the output of the what they call the AM output. Makes no sense to me, it's just a DC voltage. That's this inductor right here. So I'm going to lift one end off. That's what I had done. And I'm going to introduce a voltage into this part. Now I got to figure out which part of this, which end of this inductor, which goes to the comparator, voltage comparator, and which end goes to the connector, so I know where I'm putting the voltage. And this is where I was surprised what I found. Okay, so like I say, this is a simulation. I've already done this. And oh yeah, I can't find my glasses. Hang on. Back over here. So what I did at this point was I took my soldering gun and lifted one end of the coil off. Are we going to focus? Yeah. Let's zoom in a little bit here. This is hard to film, but you'll get the idea. So there. So I took one, and you can see the coil already. Like I say, I've already done this. So I took one end of the coil and pulled it up like that. Now I needed to figure out which end of the coil, which end of that inductor, which end goes to the op amp comparator, and which end goes over to the connector. So I take a multimeter. Now it comes off of a voltage comparator on pin 7, so that was easy enough to do. If I get on pin 7 without trying to block what you guys are seeing, 4, 5, 6, 7, go down here. No, nothing there, so this is going to be this end. There's the end of the op amp. So just for giggles, I thought, well, okay, I'm gonna go on this end here and just go on the connector itself. See which one, if I can get on there. That's interesting. I had this working before. Oh, wait a minute. Wrong end. Yeah, that's what I did. No, I'm taking it all back. I'm on the inductor because this the foil side goes to the op amp. I'm getting all excited again. So here I'm on the this side. That side there. That's the op amp. Yeah. So the other side had to be the foil. That one making some sense here. There it is. So I knew I had to put a wire down there, and I thought I'm going to go through the inductor. So I lifted up the other end of the inductor, but just I don't know, for some reason I thought, well, I'll make sure the inductor is good, and I went across the inductor. And are we seeing this? No, we're not. Yeah, you're not seeing this. Anyways, I was testing the inductor resistance, and this is what I found. I'm across the inductor. That sucker's wide open. Still not properly. Yeah, there's nothing going through this inductor. I mean, it should be a couple ohms, if anything, but there's nothing. Check my needle, my leads. Yeah, they're good. That darn inductor's bad. And this is the one that feeds off the voltage comparator. It comes off the voltage comparator. When the circuit comes around, it gets amplified and stuff, and there's a diode here that detects it, turns it into a kind of a DC voltage, into the voltage comparator, comes out of the voltage comparator, through this inductor, over to the connector, there, and then out to the audio board, and thus comes back and controls everything. That bloody coil is open. I couldn't believe it. So I thought, okay, just to prove this, I'm going to pull that sucker off and put a wire jumper on it and put it back in the IFR and see what it does. So this is what I've done. See if I can zoom in here. You can see what I've done to prove this circuit out. You saw where the inductor was before. Now I've got a wire jumper going across. Just to, I mean, it's an inductor. If it, I don't think it's going to hurt anything. That's for sure. I just want to prove the point that that darn inductor is. Well, I know it's open, so is it going to work? I know it does because I've already done this. Here's the inductor, and if I take, I'll just do it again for giggles. I'm going to put leads across it, you know, like so. I'm on the ohm meter scale. Actually, I'll put a beeper on, but nothing. Not a darn thing. Go over to the ohm meter. I'll take it off beeper just in case. Get my leads wrapped around here. You know, everything's working that way. Go up a little bit there. Oh, well, it's hard to get this thing adjusted when I got zoomed in like this. Going across the inductor. Nothing. She's wide open. So that's a good sign. So I'm just going to take it now and I'm going to put it back. Take the module, put it back on the IFR. So we'll just keep her going here camera wise. Swing it around. It's all hooked up. Actually, I got that jumper in there still. I'm gonna put that back on. So bear with me a second. What I was talking about was that I pulled this resistor off here, one end, so I can turn the AGC circuit on and off. So I want to make sure it was connected, so we're good. So we'll put her back on the machine. And see what happens. Plug in things. Got a cable here. That's hooked in, that's plugged in. We're good to go. Really don't need that. Don't need the probe anymore, but we'll leave it there. And turn it on. Enter executive RF. Yeah, we got good signal. So let me bring it over here so you can see what's going on. There's our. I think we're seeing it. Everything okay? Yeah. Put it back with modulation. Frequency here. She's working, lights on, so I'm going to, if I can get it, keep out of your way. Let's go a little closer. Going to take the generator now over here. So we're on them both. I'm going to lower the signal. And I want to check one thing. I was just going to see what the squelch is. Oh, yeah, that's right where it's supposed to be. Okay, so I'll leave it there. Plug in the generator. Yeah, sure, 63. I'm going to get less and less. You can see it on the scope. It's going less and less. There's 87, 90. Very little on the scope, and we're still our frequency meters are still working. So, I mean, oh, I got to open up scope. There we go. Still working. Still full quieting. Or, you know what I mean? Before it'd be gone. So there's 100, 105, and it's not even on the scope. So that's the end of it. First we go up a little higher, and everything's working good. So, hey, the ultimate test. I'm going to call it ultimate test. You can tell I'm giddy. Turn the volume down. Take off the generator. And where have I put it? There it is. Put on a rubber duck. Let's go over to number 1. Oh, now I've got it here. Executive RF 110. Is that FM channel? Before I had to do this to get it on there, eh? Working like a charm, so that fixed it. There's that darn inductor the whole time. Why would that inductor open up? I thought maybe I damaged it, but no, I don't think so now. If I had damaged it, why is the problem still not there? So, I gotta find another inductor. I'm just gonna find some piece of junk I got and put an inductor in there because I don't think it really needs one, but I'll put something in there for the time being. Anyways, it's working. Oh, what a struggle. Yeah, a lot of fun though. I enjoy it. So I pulled a jumper off there and had some inductors. I got it put in there. I had some 220s. Not a 470, but they're just a line filter sort of thing. It really puzzles me because I know darn well I measured voltages on that inductor, and the only thing I can explain it, maybe I was on the wrong part, but it kind of fooled me anyways. But anyways, we got it all replaced. We tested it, and it was all good. Okay, we got the board back in. We got the new inductor installed. I happen to have a 220 microfarad. It's close to 470, close enough. Anyway, so we're putting the signal into again, 145, negative 60 dBm, and we're already seeing a signal on the scope, so I mean, this has really made a difference on the performance of this thing. So I just thought I'd probe a few spots to just show you the difference. I have added 30 dB of attenuation onto this thing, because it's really picking up stuff now. This is see if I can find it. This here, I believe, is the input to the first amplifier. Look at it. Isn't that interesting? There's two little humps there now. I don't know what that's all about. Huh. Weird. And then I'll go on the output of the one amp. There's that one. And the output of the second amp, I believe, is here. Yeah. So a lot stronger. Yeah, and this is the input and output of the filters. So, I say 30 dB of attenuation. World of difference. I don't know what that second hump is. I see it there right now. The probe's not connected. I'm picking that up. And it's, it's below 1. It's like 10.7 down 1 megahertz per division, so it's 9.7. I don't know what that is. That's weird. Anyways, back to this thing. We have, go over here a bit better. Oh, I know what. No, that didn't make any difference. We've got the FM narrow again. Receive, I'm going 3K for frequency error. It's in the center. Yeah, things are working. Things are working good. I'm going to put some deviation on for the fun of it, so I can figure out how. Modulation. About 3 kilohertz. Now I got to turn that on. No, I didn't do it. Okay. I never know how to run this contraption. There we go. 3 kilohertz. 3 kilohertz, yeah. 3 kilohertz. I've got a generator. Excellent. Sure. Let's turn the modulation on and off. She's a done deal. She's working finally. Curious about this other signal. I never had that before. I'm going to look into that, see if I can figure out what that is, just for giggles. I'm a bear for punishment. I like to look. I like to look at things. So if I find something interesting, I'll let you know. Well, this is the most interesting. I don't know what this is. It's frequency-wise, it's an area of 9.9 in that area. Interesting. What I was looking at is 10.7, of course, the IF. So I did some different things here. I turned the generator on and off and played with IFR. Nothing. I never had this here before. The thing that's different is that I have this extra coax coming over here. What I did was I plugged in the back of the IFR. I was going to put an external reference into this thing, just for giggles, just to see how close the frequency error meter on the IFR is. I unplugged it. Didn't make any difference. But my external reference is coming from over here, which is my 10 megahertz reference for this thing. And It's kind of hard to get in view here, though, already playing, but you get the idea. Oops. It's this thing. This is my GPS time reference thing I use for everything else, and that's where the 10 megahertz reference comes out of there. Comes from there, it goes through a cable and back over. So what happens is if I never seen this before, it kind of blows my mind. I turn off my GPS reference. Gone. Weird. That's good to know, but what that is beyond me. Is that my reference? Hey, I got an interesting thing here to try. You know, I'm going to leave this going because it hasn't locked onto the GPS satellites yet. And I bet you, when it does, it should be 10 megahertz. It's 10 megahertz reference. Of course, I'm on 10.7. Let's open this up. Scan width. No, 1 megahertz lives in 2. Okay, let's go over here a bit now. There we go. It's my 10 megahertz reference coming out of my GPS system. So that's the signals. Boy, that's a strong signal. It's just picking it up all over the place. This RF probe is really picking it up. I think if I unplug the RF probe, and it's there, but it's not as strong, so it's coming in through this active powered RF probe. Good to know. Anyways, I do have fun. Anyways, we'll put the thing back together again, and we'll call her a night. Okay, so I did a bunch of other things to it. I checked the output against my power meters and stuff, and yeah, it's all done. She's a good deal. For a project that I wasn't going to make a video on, it sure turned out to be a long one, but oh well. I enjoy working on these stupid things, and hey, what can I say? Another good one. Anyways, if you made it this hour, thanks for watching. 73s again from Skip, Victor Echo 6, Bravo Golf Tango.